Here we have a likeness of James, one of our class members, standing at one end of the room on the other side of a chasm that suddenly appeared in the middle of the room, protected by a red-eyed ogre that didn't want us getting to James or James getting to us. I'm not sure who the ogre was protecting. We know that the position at which James was standing was 14.3792 feet away from where we began our measurements. We wanted to see how tall James was, to see if this appearance had made him any taller or more dangerous. Now what we did was we took our knowledge of this, and then we created a line of sight here, and I'll explain kind of how we did that. Let's zoom in on our information. What we did was we had a tabletop here. Okay, and across this tabletop, and we knew that the height of this tabletop was 93.5 centimeters, we strung a thread or a light string in a direction from a point on the tabletop in the direction of the top of James's head, so that we had a line of sight to the top of James's head and a line of sight horizontal, parallel to the tabletop. Knowing how high the table was, we were able to determine then how high our line of sight was in James, the same height as the tabletop, and then by the proportionalities of this triangle we were able to determine how tall James was from the height of a tabletop to the top of his head, as we'll see in a minute. So we have these dimensions, 16.2 centimeters here, 80 centimeters here, along a carefully constructed line of sight, using, again, a string. The other information is all here on the figure. James is 93.5 centimeters from floor to the line of sight along this table, assuming that the floor is level and that the table is level. And those are pretty good assumptions. In that case, the triangle that we have from here to James's head, down and back to the origin of our line of sight is the same, is similar to the triangle that's formed by our line of sight and this distance here. We simply arbitrarily measured the 80 centimeters. 16.2 centimeters here was the height at a right angle from this measurement, from this line up to the line of sight. The proportionality, therefore, is 16.2 centimeters over 80 has to be the same as this distance x from James's waist to the top of his head over the 14.3792 centimeters. That is, this side over this side is the same as this side over this side, since the triangle has the same, since both triangles have the same angle here, and they're both right triangles. Looking in a couple of ways at our results, 16.2 over 80 is 0.2025, which means that 16.2 is 0.2025 of 80, and we then conclude that x is 0.2025 of 14.38 feet. Now, I wasn't really serious about that 14.3792 feet. I didn't know the distance. We didn't know the distance that accurately. Even the 3/8 might be stretching it a little bit. But let's play the game and pretend that we do know that much. Okay, so 0.2025 of 14.38 is 2.91 feet. Again, correlating that with the figure. This height is 0.2025 of this distance. Therefore, since the triangles are similar, this height is 0.2025 of this distance. The result is that x here is 2.91 feet. Another way of getting that is to just set up a standard proportionality. X over 14.38 equals 16.2 over 80. In both cases, we have the side of the triangle opposite this angle over the leg of the triangle, with the two sides being the two that make the right triangle. And that's exactly the same triangle, of course, that we have up here. Okay, we have the two legs of the triangle that make the right triangle, and we have the ratio of those. So setting those two ratios equal, this over this equals this over this, we easily solve by multiplying by 14.38. We get x is approximately 2.91 feet. Our conclusion is that James is about 37 inches. Now 37 inches is about the same as 93.5 centimeters. Divide 93.5 centimeters by the 2.5 centimeters per inch. You come out real close to 37 inches. And then plus 2.91 feet. That's 37 inches plus 34.9 inches, or 71.9 inches tall. And this is James's height. James is 5'11.5", which would be 71.5 without shoes, and it's very reasonable that his shoes should add almost a half inch to his height. So this is a very accurate determination.